This is Dan Bjorklund. It is June 14th at 3:30 in the afternoon. We went from the frost over the May 28th weekend, got into the next week, and it's been hot ever since. And most of these hybrids out here are rolling, and they're trying to protect themselves. It takes potassium to regulate moisture. Potassium controls the stomata openings on the undersides of the leaves, and that really determines water regulation in the corn plant. From discussing earlier, we know that the top 6 inches or so is where most of the potassium is concentrated today, because basically that's how far we incorporate it versus when I started in the business 40 years ago when we plowed it twice that depth. So top 6 inches dried out, we're getting to V7, V8 corn, and there's going to be a huge uptake, a huge demand for potassium. So it'll be interesting how these hybrids respond, and we should start to see on the lower leaves some potassium deficiencies on some of these hybrids, which we've seen in the past, because some are heavier users of potassium than others based on the genetics that we're talking about. So let's take a look at some of this corn, and we're going to follow this through the rest of the season. So I'm between these two hybrids. This one obviously has more width to it. This one is very, very upright. That reminds me of what I would call that pineapple look, that sort of that B73 female that was developed at Iowa State out of the stiff stock population. Very upright. This one's got more of those horizontal leaves, so there might be some B37 in here, even B14. All 3 of those females came from Iowa State, and they were used because they were great females for combinability with the various different males. So obviously 2 different hybrids. I don't know. It's going to be interesting. I'm just going to follow this plot, stop if I see anything of interest. Like I said, 3:30 in the afternoon, 88 degrees, so it's not excessively hot like it has been. Now here's one. Yeah, it's rolling, but it doesn't seem to be as severe as some of the other ones. Roll as significantly. So the question is, if you have better root mass on one genetics versus another, so that the one with the bigger root mass is not under as much stress at the same time, is it still going to roll as severely to protect itself? Now here's one that does not seem to be as significantly rolled compared to this one. So the question is, are the roots on this hybrid just smaller to the point where it becomes under stress sooner and has to protect itself, versus this one that has a known pretty good sized root system with that southern genetics, and it's still protecting itself, but it doesn't need to do it to the same extent as this one. The only way that you can really determine the hypothesis on leaf rolling and protecting itself and which hybrid does better, is with the yield results we get at the end of the season. For 40 years I've heard you want something rolling to protect itself, and those that are most severely leaf rolled in the end will yield better than those that are not. But just when you look at them, your eyes tell you something different. So we'll see what the yield data says. Here's another southern. I mean, it's leaf rolling, but not as significantly as some of those earlier ones that are more of a northern background. And the whole idea with northerns, or iodines as we call them, came out of Minnesota, was that they were good in the heavy glacial till soil types, but they didn't like excess heat, and it would make sense that those would leaf roll more. This came from Missouri 17. My daughter lives in St. Louis, and it's hot down there. 98, I think, the last week, 95 to 98. So it's even hotter than it normally is at this time. So these plants were selected in that type of an environment and have been known to take heat stress better. Is it because they have a bigger fibrous root system? That's what they have when you look at it. But one thing about genetics is that we don't have 100% of one style anymore. There are combinations, so you need to understand the percentages. What percentage of Mo 17 does this have versus one of those others that were leaf rolled pretty significantly? Way more significant leaf rolling than that Southern. This is an iodent, came from Minnesota on the male side. High percentage of the male is that. Does not like stress, heat-driven stress. Obviously, you can see that. So again, is it because the root system is not quite as developed or not as fibrous, not as big as the Southern? That's what your eyes seem to tell you. But if this thing yields better than the Southern, even though it's rolled more significantly and looks more stressed, that'll tell us a different story. So walking by a lot of Northern, a lot of iodents. These are 99-day products in this plot, and look at the significant stress they're under. So from one company, very heavily leaf rolled, protecting itself. From another company, still protecting itself, but which one seems to be under more stress to you? This one? Or this one? What do your eyes tell you? Now, the company that developed this product is going to say, oh, it's protecting itself. Well, we will see at the end of the season when we get the yield data. I think it's going to be fascinating to take the yield data from this plot and find out which genetics actually handled the stress the best. You know, as agronomists, you wait. I've seen only 2 years like this significant, 1988 and this year. 2012, we had more subsoil going into the year, and it didn't rain in July and August. But in 88, we went into the spring just like we have this year in 2021 with only about half the profile. And I remember 88 for 3 different 10-day periods of time in July and August when it got up to mid-90s with no rain. And I know what happened there, and there were differences. Even though yields were way, way, way below normal, some hybrids were 20, 30, 40 bushels better than others. And so we will learn this year about which genetics take the heat stress the best, and we'll use that information to make recommendations for next season for diversification's sake. Hopefully not seeing a year like this again next year, but that's out of our control. So all we can do is make our observations, give you our best recommendations. Till next time.